everyone, welcome to my channel in this video. So in this video I want to tell about how we will create the universal cringing model and how it will predict. So basically in the before session, the continuation of that code. So I just predict the plot. So whereas it gives the universal cringing predictions. So it plot this like this. Okay. It was the universal cringing code. It is a red means it will very highlighted. The zinc metal it is highly concentrated in this place in the river. Okay, it is lowly concentrated. Okay. Next, I have used the linear model, Matten model, and exponential model, and for that purpose, I have shown my code. Okay, library of SP. First of all, you need to load the library of SP. Next, data of MUS. So the data of MUS it shows it load the data and it is the 155 observations of 14 variables are present in my data and of the coordinates. So like coordinates, these are the coordinates. If you want to see the coordinates, then just give the coordinates of mus equal to tail symbol x plus y. So then it shows all this. So what type of data frame and what data and coordinates and as and it is integer. What are the integers? What are the double and what it is the CRS like coordinates and what is the string project post string like it created. Okay. So I have created a sample variogram. So for this purposes, linear model or exponential model, for anything purposes, I have used it to predict only jing. So one means whereas for the one means so whatever the variables like output game like like I need to just give the jing. It is the output I need to create. And one it is like indicate. So whereas for the another variable. So I created variogram model. So did you see the variogram model? It takes the 15 observations like 60 variables. Like 15, like it takes jink. Whatever the jink values it have, then it takes. But I have given the log. So that's why the observations are vary in this place. Okay. And so I have given to take the all variables as an input. But it takes the 6 variables because I have given the log from the MUS. MUS is the MUS data set place. And I have used the VGM1 fit dot variogram. VGM1 VGM function you need to give, and lin is the linear model, and nudget it is the NA. So whereas you need to give any value defaultly 0.5, 0.1 or anything. If you don't want to give anything, then you have to place NA. Kappa it is like statistic, whereas use it for to how it will be calculated correctly or not. Whereas SSER, it is the sum of squared errors in this function. So whereas this is about all the function you need to identify how it will be performed by using the variogram model and how it fits the different models in the variogram. Okay. Next, you need to optimize. So optimize means whereas it is the minimum and objective values it print. And after you need to plot the variogram. It will be fitted correctly or not. Yes, it almost fitted correctly. Then it is called the linear variogram model. It creates on x-axis semivariants and on y-axis it creates the semivariants. On x-axis it creates the distance. So whereas this is the main, it is the title. Okay. And after the like linear model, you need to see how it performed, what are the characteristics or anything, or it will be printed as the output, that is the summary PSL range, and how it will be printed, nugget and lane. So it didn't give nugget anything, but it takes a nugget as the default value for the PSL range. Okay. And after the sum of square letters, what it is like, it is lower, so you didn't need to worry, it is the best model. Okay, M contains the fitted variogram model and Basel range nugget. Okay, print. So everything I printed like this print and fit dot variogram model. So whereas I fitted the spherical model. Okay, next I have need to do. So I load the MUS data set again. So if you load the MUS data set again, then it gives like this. So variogram model. So next I want to create the Matten model. Just you give the play in the place of lin, how give just mat. It creates the Matten model. So plot. Yes, this is a matter, Mirabelle.